So a student carries out an experiment to find the speed of sound in air. He stands facing a high cliff and shouts. He hears the echo 1.9 seconds later. He then walks 250 meters further away from the cliff and shouts again. Hearing the echo 3.5 seconds later, hearing the echo 3.5 seconds later, calculate the speed of sound given by this experiment. Now, this question, there are two ways in which you can able to work it out. So I'm going to show you how to work it out in two ways. So let's say the cliff is here. So this is the cliff. And then let's say the person is here. This is the person. Then he stands facing a cliff and shouts. He hears the echo 1.9 seconds later. He then walks away. So this is the initial. So let's say the distance initially. The distance here, we can call it x. So the time taken for the sound to travel from here, then back, that time is 1.9 seconds. Now we are told that he walks away. So the new position here, that is this. So this distance here is 250 meters. Now calculate the speed of the sound. Now we know that the speed of sound v is given by 2d divided by t. 2d is because the sound is traveling to and then gets reflected. So it will be covering twice the distance. That is one way of doing it. So for now, we can able to consider two distances. We can able to consider the first one because when the sound traveled from here, so when this guy is clapping at this particular point, so sound traveled from here to the cliff and then gets reflected back at this particular point. The time taken there is 3.5 seconds. Now, speed is given by 2d over t. The speed of sound, when we assume that other factors such as temperature remain constant, then the speed of sound should remain constant. So the first option is this. The first way of finding speed is by using this. So speed v, which is given by 2 times d, the distance from this particular point, let me call it A, then this particular point B, and then this is the cliff. Now the distance from A to the cliff, you can able to see that is x plus 250. So that means d here, d is equal to x plus 250. Therefore v is equal to 2 into x plus 250, and this divided by the time taken. The time taken for the sound to travel from point A, then back, that is 3.5 seconds. So we divide this by 3.5 seconds. Now this is equation 1. Now equation 2, we can able to use this distance here, x, from B to the cliff, because we have that time taken. The time taken from B to the cliff is 1.9 seconds. So v, which is given by 2d over t, the distance there is x, divided by the time taken, which is 1.9. As I said before, the speed must be equal, so this v is equal to this v, and therefore we can able to equate equation 1 and equation 2. Now, so equating equation 1 and equation 2, we're going to have 2 into x plus 250 divided by 3.5. We multiply, this should be equal to 2 times x, that is 2x over 1.9. We can open the bracket, so that will be 2x plus 500 divided by 3.5 that is equal to 2x over 1.9. We cross multiply, so we're able to find 1.9 into 2x plus 500 is equal to 3.5 times that will be 7x. So 1.9 times 2x, that will be 3.8 x plus, can confirm, I have a calculator here. So 1.9 times 500, that is 950, which is equal to 7x. So therefore, 950 is equal to 7. That is a 7, that should be 3.2. 3.2x. Divide both sides by 3.2. 3.2. So you find x to be equal to 950 divided by 3.2. That gives us 296.875. Now, from here, if we want speed, we can able to use one of the equation, either equation 1 or equation 2. I'll use equation 2, so therefore v is given by 2 times distance x, which is 296.875 divided by 1.9. That gives us times 2 divided by 1.9. This gives me 312.5 into two significant figures. My answer will be 310 meters per second. Now, option 2 is to work out with this, with the difference between the timing. If the time taken from point A to B and back is 3.5, the time taken from point B to the cliff and back, that is 1.9. So what if we assume that this cliff is here, is where this person is originally, and then the person is at point A because he moved away 250 meters away. If we assume that the distance here between A and B is 250, then the time here will be the difference between 3.5 and 1.9, which will give us the time as 1.6 seconds. So using this equation, that v is given by 2d over t, which I've already explained why we are multiplying d by 2. So we have v is equal to 2 times d, which is, so d is what we're looking for. Sorry. We already have d. D is 250 divided by the time, which is 1.6. Sorry. So 1.6, and when you work out with the calculator, so that is 2 times 250, that is 500. We divide by 1.6, we get 312.5 meters per second, which is approximately equal to 310 meters per second in two significant figures. Thank you, and that is enough for today.